Greetings, everyone. Glad you joined me, Mr. Roundy, for another lesson. Today's lesson, we will teach you how to solve two-step inequalities. The steps to solving a two-step inequality problem are the same as solving a two-step equation. However, there is one rule that you have to remember with inequalities. Whenever you multiply or divide by a negative number, you must flip the sign of the inequality. Now, I think it's time to look at some problems. Here we have our first two-step inequality problem. 3x plus 4 is greater than or equal to 16. We notice that this looks a lot like an equation. The only thing that's different is the inequality sign. So what I like to do is I like to change them out and just write it like it's an equation. Sometimes that just makes better sense for my brain. And I remember that when I solve two-step equations, I start by doing the reverse order of operations. So normally you do parentheses, exponents, multiply, divide, add, subtract. But when we're trying to undo an equation, we do them in reverse. So we first get rid of or undo all of the add, subtract that are by the variable. So I'm looking here at my variable, and the only add, subtract I see is the plus 4. I'm going to subtract 4 from both sides, the addition property of subtraction property of equality. This side cancels out, and this side leaves me with 12. I now have 3x equals 12. The next thing I do to undo and get my variable by itself is I'm going to undo the 3 times x. And I undo it by doing the inverse operation or divide. And I'll divide on both sides, the division property of equality. And this one cancels out, and I'm left with x equals 4. However, I have to remember that this wasn't actually an equation problem. It was an inequality problem that had a greater than or equal to sign. So I'm going to have to change this sign to greater than or equal to. I didn't multiply or divide by anything negative, so my inequality sign doesn't need to be flipped around. Once I've got my answer, I could then work on graphing that answer on a number line. So I'm going to draw my number line up here at the top. And I notice that my 4 is my leftover number, or the number that's part of my inequality solution. So I start 4, 5, 3, and I'm going to draw a closed-in circle because it's a greater than or equal to. And I need my x needs to be numbers that are greater than 4. So I've got to show with my arrow the numbers that are greater than 4, and that's going to go that direction on the number line. For our second problem, let's look at an inequality that's going to require us to use our negative rule. This inequality says 7 minus 2x is greater than 11. So we need to start solving it by working to get the variable by itself. The two things that are, or the two numbers that are on the same side of the inequality as the variable are 2, but it's got this minus sign in front, so it's really like a negative 2, and 7. So the first thing I want to do is get rid of any add, subtract that are happening, and then multiply, divide. Well, the 2 is being multiplied with the x, so I won't get rid of it first. What I'm going to do is first get rid of the 7. Now this is a positive 7, so I would have to get rid of it by subtracting 7 from both sides of the inequality. This one will cancel out, and this side is going to leave me with 4. Over here, I still have this minus sign that was going in front of the 2, so it's like a negative 2x is greater than 4. I'll now get rid of the multiplication by dividing. So I will divide by negative 2 and divide by negative 2. This will get the x by itself, and on this side, 4 divided by negative 2 gets me negative 2 because the signs did not match. Now, since I was dividing by a negative number, I have to use the rule that says when you divide or multiply by a negative number, you must flip the sign of the inequality. So I'm going to flip it around so that it's a less than sign instead of a greater than sign. And my solution is x is less than -2. And I can graph that on a number line right here. If I say this is -2, -1, -3, and this is going to be an open dot because it doesn't have the equal to part on the sign. And now my numbers for x need to be less than -2. So if they're going to be less, that means it's going to be going to the left, and my graph is going to go that way, to the left for my arrow. For our third problem, let's look at an inequality that has some division in it. Our problem here says x divided by 2 minus 5 is less than -8. We've got to start solving our problem by getting the x by itself. Now, like I've said before, I sometimes like to change it out with an equal sign so it looks like an equation at first. So I've got to start getting it by itself. I want to get this x alone. It's being divided by 2, and it's also having 5 subtracted from it. The reverse order of operations tells us that we should get rid of any add subtract first. So I'll get rid of the -5 first. I'll add 5, because that's the inverse of subtraction, and I'll add 5. Here it's going to cancel out. Over here, we're going to get -3 equals x divided by 2. Now, to get rid of division, I'm going to have to do multiplication. I'm going to multiply by 2, and on this side, multiply by 2. These ones will cancel each other out, and -3 times 2 is going to get me -6. So x will equal -6. I didn't multiply by a negative number, and I didn't divide by any negative numbers, so I won't need to change the direction of the inequality sign. Originally, it was less than, and so it will stay less than. So we have x is less than -6. Now, if I want to graph it, I'll start with -6 at the middle of my graph, -5 as it gets bigger, -7 as it gets smaller, and it's going to be an open circle because it's not an equal to. And we need our numbers for x to be less than -6. So that means our arrow is going to go to the left. And we have our graph. For our final problem, let's solve a two-step inequality word problem. Our word problem says, halfway through the bowling season, Stuart has 34 strikes. He averages 2 strikes per game. Write and solve an inequality to find how many more games it will take for Stuart to have at least 61 strikes. Interpret the solution. The first thing we need to do if we're going to write an inequality is figure out what our variable is, the thing that we don't know. The thing we don't know in this problem is how many games it's going to take. So I'm going to use x as a variable to represent the number of games. Now in the problem, it says Stuart already has 34 strikes, and he's averaging 2 strikes per game. Well, 2 strikes per game sounds like a rate, and rates would usually be written with the variable like this. 2 strikes per game, or 2 times the number of games. He also already has 34, so to find our total, we'll need to get how many he's getting each game plus the 34 he already has. At the end of our problem, it says it wants us to find out how many games it will take for Stuart to have at least 61 strikes, or strikes. At least means greater than or equal to, and it needs to be at least 61. So our full inequality would be 2 strikes per game plus the 34 that he already has needs to be at least or greater than or equal to 61. Now to find out how many games he's got, we've got to go ahead and solve. We're going to first get x by itself by getting rid or undoing any add subtract. So I've got to add here, I'll subtract 34 and subtract 34. Here it's going to cancel out. And on this side, it's going to get me 7, 2, so 27. I now have 2x is greater than or equal to 27. I'm going to undo timesing by 2 by dividing by 2. And I'll divide by 2 over here. 27 divided by 2 gets me 13.5. And x is going to be greater than or equal to 13.5. Now the last part of our problem says interpret the solution. Well, our solution, as we wrote it, is x is greater than or equal to 13.5. What this means is that in order for Stewart to get at least 61 strikeouts, he's going to have to bowl for 13.5 more games to get greater than 61 strikeouts. So our x, or the number of games, needs to be greater than or equal to 13.5. That's the end of our lesson. Thanks for joining me, Mr. Roundy. Have a fantastic day.